Thank you so much, and thank you for holding out until lunch. I promise I will keep your attention, I hope. This is the Buck Institute. It's located just north of San Francisco, and it's the first independent research institute that was wholly devoted to understanding mechanisms of aging. And I run a research lab there, as she mentioned, but I'm also founded and am directing a global consortium around reproductive longevity and equality. Now, I know that the men in the audience often tune out when I say reproductive longevity, but I hope by the end of this I'll have convinced you that this is a really important topic, not just for women, but also for men, for young and for old. So, soon there are going to be more people over the age of 65 than under the age of 5 for the first time in our history. So aging is really a public health pandemic. And thanks to scientists working at the Buck Institute and in other places, we now know that biological aging is malleable. And so if we can target the mechanisms of aging, then we can tackle all of these diseases at once. Now, as we make headway in healthy longevity. Essentially, what we're trying to do is to extend health span, not lifespan. So everyone in the audience is probably familiar with this graph where different systems in your body decline over time in a systematic way. But what we want to do is basically to compress the period of time at the end of life when disease is happening, to extend the number of years that someone is healthy. And essentially, female fertility completely falls off this curve. So it's the very earliest hallmark of aging, and it's also the most robust feature of human aging. So ovaries are declining at approximately 2.5 times the rate of the rest of the tissue. We think about them as a pacemaker for aging in a human female. And essentially, ovaries are they're declining at an accelerated rate. And as we're making progress in extending healthy longevity, if we don't address ovarian aging, then we're going to make gender inequality worse, not better. And that's because menopause makes a woman's body age faster. So it can speed up cellular aging by almost 6%. And even in healthy women, the end of fertility essentially sets off a cascade of negative health effects in a woman's body. So it increases the risk of cognitive decline, heart disease, stroke, osteoporosis, just to name a few. And truly, we think about this as an issue of equality. And that's because, independent of whether or not a woman wants to have biological children, the fact that she's going to go through this reproductive decline in midlife essentially affects every aspect of her health and well-being. So from the time that I went through puberty, every decision that I made was overshadowed by this idea that this biological clock that was ticking in the background. My decisions about career planning, family planning, my overall health. And since women today, who are born today, are projected to live almost 100 years, if we don't push out, change reproductive span, or the age at which a woman goes through menopause, then women are going to be living more of their lives in this compromised health state than before. And although women do tend to live longer statistically, they spend more of their lives now in a compromised health state. So on average, women spend 34 years in a declining health state compared to men who spend about 26 years in a declining health state. So I'd like you to stop for a minute and just imagine what it would be like if we lived in a world where women weren't constrained in their choices by this immutable biological clock. If they were free from the detrimental health effects of menopause. So this is what we're working on. This is what we're trying to do. So stick with me for a moment. I think a lot of people don't realize that human females are born with all of the eggs that they're ever going to have. So by 26 weeks gestation, a female fetus has about 6 to 7 million eggs. And those are the only eggs that she'll have for her entire life. So even though I was born in the 1970s, the egg from which I came was made in my mother's ovary inside my grandmother's womb in 1956. So it's kind of like sci-fi when you step back and think about it. And once I was born, that number declined already to about 1 million. And this graph, which shows the number of eggs and the quality of eggs over time, is something that most women are very familiar with. And by the time I reached puberty, the number of eggs I had declined to about 350,000. And then once a woman starts cycling, she loses about 1,000 eggs per month. And taking birth control doesn't change that. And of course, when a woman runs out of eggs, that's when she goes through menopause. So on average, this curve is absolutely true, but at the level of the individual, it's completely wrong. It's completely false. So each individual woman has her own reproductive trajectory, and it's very stochastic, it's cyclical, and it's maybe one of the most complex signatures of human health, and we need to treat it that way. So the men in the audience might also be interested to know that a woman's reproductive span, so the age at which she goes through menopause, is correlated with her overall lifespan. Now, that means that women who go through menopause later tend to live longer, and the converse is also true. But brothers of women who go through menopause later tend to live longer as well. So there's a genetic component here that's important across the sexes. And we don't understand why reproductive span is correlated with overall lifespan. We don't understand really basic things about how this works. Menopause is also not a biological imperative, so within the animal kingdom, humans are very strange. It's just us and 4 species of whale that go through menopause. So it's not something that needs to happen, and so we'd like to either push it out or get rid of it. But we don't understand really basic things about how it works or why it's happening. So essentially, looking at this curve, we don't know where along this trajectory the causative factor, or cue, or timer, or constellation of cues and timers happens that so reproducibly tells a woman's ovaries to start declining when she's in her late 20s or early 30s. Essentially, a woman's ovaries are considered geriatric by the medical community when the rest of her tissue is functioning at peak performance. So what we'd like to do is to answer those questions. What is the cue or timer that sets this in motion? And then to intervene to either slow down or just get rid of it altogether. And there's a profound cost to menopause to the world. So by 2025, it's predicted that over 1 billion women worldwide will be in menopause. And that has economic costs in the form of extra healthcare costs and also costs due to lost productivity, because the vasomotor symptoms that are associated with menopause, things like brain fog and trouble sleeping and hot flashes, these things actually profoundly affect a woman's quality of life. And so there's a huge economic cost that everyone should be concerned about. When I talk about this, a lot of people will ask me, well, how is it possible that we don't know the answers to these very basic questions? And the truth is that the women's health in general has been underfunded, but women's health with respect to aging is specifically very, very underfunded. So this is statistics from the National Institutes of Health, which is the largest public funding body in the United States. In 2018, about 15% of the overall budget was devoted to all of women's health. So that means from conception through death. And less than 1% of that was devoted to female reproductive aging. Now that's changing. But essentially, before 2016, almost all of biomedical research was done in male animals. So the female sex has just been understudied in general. Now that's also changing. In 2016, the NIH required that grantees use both males and females in their studies. But just generally speaking, we have about half a century of preclinical data that's only collected in males. So there's just a dearth of information here. So what we did a few years ago in partnership with the Bia Echo Foundation was to start a center, the first center in the world devoted solely to studying female reproductive aging, with the goal of understanding how it works and then intervening. And once we did that, we realized that if we wanted to have a real impact, we needed to do something much bigger. So 2 years ago, we funded a global consortium. And the global consortium is devoted to basically growing the ecosystem, to build the scientific research field in order to achieve these lofty goals. And since we're building something from the beginning, what we're doing is trying to facilitate but also accelerate, taking basic discoveries at the bench, so in the lab, and translating them into the hands of women faster. So to do that, we've got a lot of things happening, but the key, at least to start with, was actual grant funding. So science can't be done without research dollars, and so we're funding grants to basic scientists all over the world. We funded our first round in 2020 to 23 scientists, and we'll fund another round coming up in 2022. And we plan to do this every single year. So we're funding grants, but then we're also trying to build the infrastructure and provide resources to those grantees and to anyone else who has an interest in the space. So to do that, we built the first ovarian biology core facility. So this is a place where scientists who don't necessarily work in this space can collaborate with scientists to learn how to do that work. And part of this, too, is building out a network. So we're trying to bring anyone who has an interest in this space, funders, people in biotech, people in medicine, scientists themselves. We're trying to bring them together in a collaborative dialogue. Essentially, we want to push things forward faster by forcing interactions between people who might not normally interact. So I spend a lot of time talking to clinicians and getting them to work with scientists, fostering partnerships and collaborations between industry and academia that go beyond traditional models. So this is a lot of what we're doing. Then we put together a translational advisory board to help our scientists recognize things that are translatable earlier. So this is what our network looks like right now. And when we did our first round of granting, we implemented a novel blind review process to get rid of not just gender bias, but also institutional bias, because we want this to be global. We want to pick up all the scientists in the world who have an interest in pushing this forward. And as a result, 82% of our first grantee group was women, which I'm really proud of. These are some of the projects that we funded. So just a smattering, and you can look at our website if you're interested in learning more. But thinking about new models for menopause, you've heard a lot about this today and yesterday. For biomedical research, it's really key that you have the right model. And right now, we don't have any good models for menopause. So we funded some grants in that space. We funded some grants to look for new biomarkers and diagnostics around where a woman is in her reproductive trajectory. The tools that we have right now are rudimentary. We take a woman's temperature. We take a static snapshot of a very dynamic, fluctuating system. So we're trying to fund that. We've also funded grants to look at specific therapeutic interventions in ovarian aging. And my own personal interest, looking at how the brain controls reproductive aging. So coming back to why everyone in the audience should care about this, the diseases that happen after menopause are diseases of aging. And the cellular and the mechanisms that are operating there are the same. So the things that we care about and that we know about already with respect to aging, things like changes in metabolic function or mitochondrial function, senescence, increased inflammation. And the therapeutics that we've already discovered, metformin, rapamycin, NAD boosters, those are all also operating in the ovary. So the ovaries are an accelerated human model for aging in the rest of the body. And if we can understand what's causing ovarian aging, then we will understand something about aging in the rest of the tissues. But more importantly, and especially right now, there's a huge interest in the longevity space to fund companies around aging. But all of those companies are going to face the same problem, right? So if you've got an intervention that you think is going to help with human aging, how do you test it, right? So right now, we can test it in animal models, naked mole rats, worms, mice, rats, and dogs, actually. Dogs might be the best model that we have right now. But what we really want is a time machine, right? Because we want to test things in humans, but humans live too long for anything to be reasonable. But ovaries are that time machine. So you could imagine testing interventions in a clinical setting using ovaries as the output. So in this case, testing something in a 33 or 34-year-old woman, following her for a few years, and measuring simple outputs like fertility, osteoporosis, things like that. So this is a really profound advancement, I think, in terms of human health. So I want to bring it back here and ask you to think again about what the world would be like if we could just push out the age of menopause. It would change a woman's ability to control her reproductive trajectory. It would also get rid of this incredibly detrimental health landscape that happens to women after menopause. So part of building out the network is actually galvanizing and organizing non-scientist leaders to spread the word about what we're doing. So we need sustainable funding. We have this amazing seed funder in the form of Bia Echo Foundation, but we need more funders to help us with this work. We also need ambassadors to spread the word. So we have a white paper, we have a website. I'm happy to talk to anyone who has a question or is interested about this. But if you could, tell people about what we're doing, explain to them why ovarian aging might be important, not just for women, but for everyone, I would greatly appreciate it. And finally, I need to thank the Bia Echo Foundation and the Sergey Brin Family Foundation, who both funded this work. And thank you for listening.
Hi, Jennifer.
Hi.
So before the biological clock for food is ticking, let's talk about our clock for the questions that is coming up. Tell me, why do we still have that problem that women's sort of health issues are not being funded in the same way and not being looked at, and that the studies are not on the same level as with men? What is the real problem? Are we not pushing enough, because we are already 50% of the population? So are we doing something wrong as well?
I think things are changing, but I think historically women's health has been treated as a niche area, right? As opposed to being something that affects half the population, it's been approached from the perspective of diseases of the reproductive tract, breast cancer, ovarian cancer, infertility. And what we need to do is take a more holistic approach, right? We also need to acknowledge that the female physiology is not noisy, it's not a confound, it's actually important, right? I mean, this is why I remember the first time that I was, as a scientist, that I was told not to include female mice in my studies because it would make the data noisy. But that noise is actually a biological signature, right? And so these are the sorts of things that are really important to acknowledge. And I think just making more, just bringing more attention to this issue is really what needs to happen.
And what do you think are some myths and misconceptions that exist still about women's health in their reproductive lives?
I mean, there are so many misconceptions. The idea that the 28-day cycle, that's a total myth. I think something like 12% of cycles actually conform to that 28-day window. I think a lot of women don't know that their ovaries are declining in function so early. Most women are unpleasantly surprised to learn that when they go to try to use them, right? And that's something that I think there's never a moment in our adult lives when we get any kind of education around fertility or reproductive function, right? We all have some sort of sex ed class in junior high, But as an adult, I personally never got any education about this at all. So again, having non-scientist ambassadors talk about this and really just bring this issue to the fore, I think is really important.
And we have a question from the floor.
Yes.
And maybe you can also elaborate a little bit more what you think is important for checking out ovarian aging, because the question is the objective to being pregnant until 60?
This is a good question. And this goes along with, not trying to make people live to be 800. We're trying to extend health span. In the same way, we're not trying to make women have babies when they're 70. It takes a lot more than functioning ovaries to have a baby, a successful pregnancy. There's a lot of other things that need to be intact. Having said that, I wouldn't tell a woman what to do with her body. If someone wants to have a baby when they're 70, I can't imagine why you would want to do that. If you've got everything going,
why
it's
not?
not my business.
You mentioned already you are trying to collect data and get people on board globally. And how do we increase intellectual cohesiveness, data sharing, and global profile that helps us better achieve research and innovation outcomes?
Yeah, that's a really good question. So we're building a network communications platform, and this was, it was initiated because it's not that there was nobody working on this issue. There were scientists spread around, sort of isolated, in departments that had nothing to do with reproductive aging. And so we put together this network communications platform to both provide a forum for discussion and interaction, but then having a back-end platform where scientists can share data, unpublished data, discuss collaborations that basically crosses international time zones and things like that. We're also organizing this reproductive aging meeting. It's going to be the first international conference on this topic next June. And rather than just inviting scientists, we're also inviting clinicians. We're trying to foster this dialogue again. We're going to embed journalists. We're going to invite people from biotech and pharma and investors, and we're going to make this something bigger than just a scientific conference.
And you were mentioning before that communication is key, that really people know about this.
Yeah.
You have also a podcast. So is this your way of trying to reach out to make this not a niche topic, but really a mainstream topic?
Yeah, I think that truly, if we can understand why ovaries are aging prematurely, and it's such a good model, then we can understand aging in general, right?
What would be sort of your idea of what's coming next? So understanding how ovaries are aging, what would you hope for to really have at some point something that women can actually take to slow down the process? Or what would you be thinking of really changing that aging process around?
Yeah, I think that's the moonshot, the idea that you could have an intervention that would slow it down. I think on the short time scale, there's several really just like low-hanging fruit. The thing to understand is that this is not rocket science, right? These are answerable questions that just need scientists working on them. But on the short-term scale, I think things like biomarkers and diagnostics, that's very easy. And then, on the longer scale, realizing some of these cellular targets like mitochondrial function, inflammation, and seeing therapeutics grow up around those. Yeah.
Thank you so much for taking the time, Jennifer. This was great to have you here
Thanks
on our
for having
Frontier
me.
stage. Thank you so much, and good speed.
Thank you.